All right, so in the final part of this lecture, we're going to look at how we can more specifically compare different theories in light of the data we've gathered and other criteria and decide which one should have our preference. As you remember in the previous part of the lecture, we talked about you shouldn't just look at how well your preferred theory predicts the actual data. You should always make a comparison. So does it do any better than any other competing hypothesis or a theory that you might think of? And then in this part, we're going to talk about how to make that specific comparison, not only in terms of how well does it fit the data or predict the data, but also in terms of other criteria that you should consider as well. All right, so let's get started. So we could use as an example the following question, which I introduced in the lecture, which is, well, if you need to make a tough decision, perhaps for your bachelor specialization, perhaps you wonder what different types of theory do we have about what is the best way of going about making that decision. And I've already introduced two competing hypotheses, if you will, that we can use in all the examples we're going to discuss. One has to do with, well, both have to do with how we could explain that it's potentially delivers a good payoff if you not think too hard about the decision you need to make, right? Sleep on it a bit, let it linger, and then stuff will work itself out. So you could formalize or be more specific about why that should work, right? Not think too hard about your decision. And one explanation is that introspection leads to the deterioration of choice quality, right? So because you're overly focused on some aspects of the decision, that will mean that you decide on whatever comes to mind, and that's in the end not perhaps the best reflection of what you actually prefer. And the other explanation has to do with unconscious thought. At least that's what Dijkstra has believed is happening when you let that decision linger for a while and focus your attention elsewhere instead. And he says that unconsciously you can process more information, and that makes for a better decision instead of thinking about it consciously. So we have two different competing hypotheses, right? And we're going to summarize it a bit bluntly. And one says that conscious thought leads to worse decisions, and the other says unconscious thinking leads to better decisions. So which one should we prefer, and how do we decide between the two competing hypotheses? Well, what we're talking about is an example of abductive reasoning, right? So in spite of what Popper proposed and what we talked about in a previous part of the lecture, what researchers actually do is abductive reasoning. So we reason towards the best explanation. We try to argue this theory, if it holds, would offer the best explanation for the data we've found. And then the question becomes, what actually constitutes the best explanation? Which is what we're going to talk about now. So we need to look at descriptive adequacy. And descriptive adequacy is basically a fancy way of saying how well does it fit the data, right? Or does it fit the data? And a theory, and that's the primary concern, of course, as a scientist, empirical scientist, is whatever theory we have, we try to fit it on the data that we have, and we try to see whether it's descriptively adequate. So there's some research on the choice quality and the difference between conscious thought and unconscious thought, if such a thing exists, on choice quality. And if you were to find, for example, as you can see in the 12 aspects condition here, people that think unconsciously, so focus their mind elsewhere before they make a decision after seeing all the choice relevant information, do better than people that decide consciously. So that fits with the unconscious thought theory, right? Unconscious thought outperforms conscious thought. But it also fits with the competing hypothesis, which says that introspection leads to worse decisions. So again, bluntly summarizing, theory A says worse decisions because of conscious thought, and theory B says better decisions because of unconscious thought. And if we just look at the right side of the graph here, the result would be descriptively adequate in light of both these theories. So what then, right? We should move beyond descriptive adequacy and to be able to decide between these two theories. That is the case in this specific example, but it's also the case in general, right? In general, you could say, and this is more of a philosophical argument for why you should move beyond descriptive adequacy, you can always think of alternative models to the models the model you're interested in, or you just try to fit the data that fit the data equally well, right? An example would be, a silly example would be, I have two theories. One is all emeralds are green, and the second one is all emeralds are blue, which means they're green until the year 3333, and then they'll all turn blue. So if you look at all the available data, all the emeralds that have existed up until now, both theory would fit the data equally well. It won't be until the year 3333 that we're able to differentiate between the two competing theories. This is a silly example, but it shows you that you can always think of an alternative explanation that is equally predictive of the data that have occurred. So that's a more fundamental reason for moving on beyond just looking at descriptive adequacy. And look at the other criteria in the list, one of which is precision. So if you have two theories and they're both descriptively adequate, you need to decide on the basis of different criteria which one you should prefer. And one of which is precision. So the more precise theory should be preferred over the less precise theory. And in terms of precision, we mean that you can have a very general broad theory, right? So we talked about the representativeness heuristic in the previous part of the lecture, and I mentioned that that's not a very specific way or precise way of predicting outcomes. Instead, it could lead to more precise, conflicting more precise predictions, even given the same one-word explanation, right? We talked about it in the previous part of the lecture. So that also shows you why you should be more precise, because a more precise theory can be better tested as well, and it allows you to better differentiate between competing hypotheses as well. One way of getting more precise theories is using formal instead of verbal models. Let's give you a couple of examples. So if we talk about a verbal theory about how much people value money, a more verbal description could be that once you become rich, you value a further increase in money less so than if you are poor, right? So if you give a person who has $0, $100, they will be madly excited by the prospect of having $100. But if you give $100 to a person who already has $100, the amount of excitement for getting the same amount of money will be less in that case, right? So further increases in wealth, we're decreasingly sensitive to further increases in wealth, as economists would probably say it. And that's, as I just stated, a verbal theory. But you could graph the same prediction using a formal model, right? So you're basically saying our increase in subjective valuation of increases in objective value, right? More dollars and let's say more happiness is not a straight line. It's not linearly connected, in the sense that initial increases in wealth will be more appreciated than further increases in wealth will be. So what I've shown you is a formal version of the verbal theory that I just gave you about subjective valuation of objective increases in money. You could do the same with the relationship between arousal and performance, right? I could describe to you there's an optimum point at which your medium arousal will lead to an optimal performance, and I could be more specific about it and use a formal model which would show you a more precise description of the relationship between arousal and performance. This model will return in the weekly assignment, by the way, in the next week, the final weekly assignment. Another example of how using a formal model could lead to more precision, or making a theory predictions from a theory more precise, is the Rescorla-Wagner model. Again, you could talk about this in a verbal way, right? So if a stimulus is followed by reinforcement, relationship is strengthened. Cells that fire together wire together. It's so difficult to learn something very well, right? So those are all verbal statements about the process of learning, and you could make those more precise by using a formal model. A formal description of the Rescorla-Wagner model would be the following. It states that changes in association strength are predicted by or equal the learning speed described by alpha times the difference between the current association strength and the maximum association strength. What you can then do, because you've formally described the relationship between all the variables involved in learning, is you could use different values for these the parts of this formula, and you could simulate what happens, right? As I've did in this example. So your formal model of the relationship between the changes in association strength based on learning speed and the current association strength and maximum association strength is depicted here. And then you can see whether this curve, the learning curve as shown here, actually fits actual data that you could collect in experiments. And it turns out that it does quite well, as described in the reading as well. The Rescorla-Wagner model is in line with a whole host of conditioning experiments and research, neurological research as well. So you could say that the descriptive adequacy of this formal model is quite good. And if I were then to ask you, for example, we have two different models. Let's say I pick one of these more vague verbal models. It's very difficult to learn something very well, and I have the formal version, right? The more precise description of how association strength changes over repetition. And I look at the data. Let's just assume that this is the data. I could claim that both theories are equally well supported by the data. But I should also recognize that one theory, the formal model, is more precise than the vague verbal model here. So I should prefer the formal model instead in this case. So we talked about precision and the upside of precision for better testing your theories. There's a downside to using more precise formal models as well, which is overfitting. If you, for example, gather data depicted here by the different dots, and then you fit a model in such a way that it goes through all those data points, you have a model which is perfectly descriptively adequate, right? It describes the data in a perfect manner. But if you would construct your formal model in a way that it fits all the current data in the best possible way, you're not just modeling the signal, right? You're also modeling potential noise, and noise has the tendency to change over time if you collect more data. So what it means when we're overfitting a model or constructing a highly precise model on the basis of our current data set, it means that the degree to which we are able to describe the current data set, if that becomes very high, it will probably go to the detriment of generalizability of the model, right? That just means that if I've overfitted a model, that model will not describe future data very well, compared to if I used a more general model. So there's a balancing act, if you will, right? So if you have if you use a less complex model, a more general model described by the thicker line here, then that could be more robust, could be better predictive of future data as well. So bear in mind that trade-off when we talk about precision. It has to do with precision, also with parsimony, and of course generalizability, as just pointed out. All right. There is another trade-off involved in making models more precise, or at least making models more complex, and it's called the Benoni paradox, which means that if your model, you could potentially make your model highly predictive, but also highly complex, and to the degree that that complexity increases, you're less able to understand what you're actually modeling, right? It's a bit like the algorithm Google uses, which is automatically updated all the time, which does very well predict certain outcomes, but nobody actually can explain why it predicts certain outcomes. Right? It's similar to the curly fries you talked about, right? There's a predictive relationship between curly fries and IQ scores, and perhaps it's a robust predictive relationship, and perhaps it's useful as well for marketing purposes, for example. But we are unable to actually explain why that relationship occurs. We don't have any causal mechanism to use to describe that relationship. So that's a second potential downside of using more precise or complex models. Okay, so we looked at descriptive adequacy and we've looked at precision. I would argue that both theories we talked about so far, right? So conscious thought leads to deterioration of choice quality, and unconscious thought leads to the improvement of choice quality, are not very precise in their predictions, actually. Perhaps you could give a slight edge to the unconscious thought theory because it makes a difference. It predicts different results for complex versus easy choices. But yeah, that's up for you to decide. As long as you understand the difference between being more precise and less precise in models that are equally descriptively adequate. All right, let's move on to the third criterion, coherence and consistency. And let's apply that to the theories we're talking about. So coherence has to do with the extent to which something connects with... consistency has to do with the extent to which something connects with existing theories and other existing theories, and coherence has to do with the internal coherence or the internal logic of the theory that somebody proposes. So an example that we already discussed in the first year is that if somebody were to have a theory that would state that would say that men would have more intimate relationships than women in a heterosexual pool of subjects, you should scratch your head and think, well, how is that possible, given that in that heterosexual pool of subjects, it doesn't really make sense for the man to have more intimate relationships than women. It's also described in the reading, by the way. In the same way, we can think about the internal logic of the unconscious thought theory, because unconscious thinking is described as choice-relevant processes without attention, which is all well, but then it becomes difficult. So if we say that unconscious thinking is choice-relevant processes without attention and conscious thinking is a choice-relevant process with attention, then we can conclude that distraction excludes conscious thinking, but it doesn't exclude unconscious thinking. But that then makes you wonder, how could you predict a benefit of unconscious thought, right? Because if unconscious thought is still taking place, if you are paying attention to making the decision, right? Because conscious thought is whatever is happening here plus attention, right? Then why do all those benefits of unconscious thinking not materialize if you are paying attention to what you're deciding on? That's a weird differentiation. Again, it's not about the unconscious thought theory here, but it's an example of checking out the internal coherence of the theory and saying it's a very weird way of differentiating between unconscious and conscious thinking. So it's unclear to me how the benefit of one-way thinking would materialize if there's such a huge overlap between the two modes of thinking. So we've looked at coherence. Consistency is also interesting to look at, right? Because basically what they're saying is if I'm distracted by doing something else, I will perform better and make better decisions. And that's also not very much in line with the literature on heuristics and stereotypes, right? That basically in most of that research, to the degree that people are cognitively overloaded, they tend to rely on heuristics more and on stereotypes more than, which wouldn't really align well with saying that they probably make better decisions in those situations. So for now, I've just applied it to an example as an example, of course, but for now it's important that you know that coherence has to do with the internal logic of the theory and consistency has to do with the connection to existing theories as well. And you should check for both when trying to decide which theory you prefer. Falsifiability is, of course, an important criterion as well. So in a way, you could say that both theories are falsifiable in the sense they make a prediction that can be falsified, potentially be falsified by collecting data. But we need to be more specific or more detailed in our description of falsifiability, because as the reading points out, the Dina's reading for today points out, you can talk about degrees of falsifiability. It's not that interesting to say, well, both theories are falsifiable and we're done. No, we need to be more specific about what we mean by falsifiability. So first of all, falsifiability is indeed the capacity of a theory to make predictions that can turn out to be false. So a researcher needs to do all she can to be as specific as possible about the circumstances under which we can show that a theory doesn't hold, or turns out circumstances that would show, or data that would show the theory to be false. It's also related to the disposition of the researcher, right? We should do everything we can, everything in our power to try and prove ourselves wrong. It's that bending over backwards as well. And that's covered by the falsifiability criterion as well. It's not necessarily, does it lead to a falsifiable prediction? No, are you doing everything you can to try and falsify that prediction as well? And that's connected to making the test of your theory as difficult as possible, or using stringent tests. It's basically like training a boxer, right? Before a match, you want to expose that person you're training to the most difficult of circumstances, so you're sure that whatever comes out of the other end of the training is as strong as possible, right? So you're constantly mindful of the circumstances under which you could falsify your theory. You're doing everything you can to expose your theory to tests that could potentially falsify it as well. Plus, you're making your theory as falsifiable as possible. And then we're talking about degrees of falsifiability. And that means that some theories are more falsifiable than others. And that's the way in which we can most sensibly use this criterion for deciding between which theories have our preference. A theory is more falsifiable if it contains more classes of falsifiers, which basically means more types of data that could, or patterns in the data that could disprove the theory. So basically, the more a theory excludes, right, the more situations or potential data sets that are not in line with your theory, that are excluded by your theory being true, the better falsifiable your theory is. You're basically saying, if I have a theory that says that and that and that and that and that and that can't happen, if my theory holds, then your theory is more falsifiable than a theory that says, well, everything is allowed. Anything that could happen and my theory would still be true, right? So if you compare those two, you would say the first theory is more falsifiable than the second one. To make that latter statement a bit more precise, we can look at the relationship between choice quality and alcohol, right? So if I make the statement, choice quality depends on alcohol consumption, then that's a very generic statement. And you could say that statement is not as falsifiable as the statement alcohol consumptions result in poorer choice quality. Basically, what you could say is that choice quality depends on alcohol consumption. You're basically saying there is a relationship between these two variables, right? You're basically saying the only situation that's excluded by this theory or this statement are the flat lines depicted in red. Right, so there's a host of different relationships that you can find depicted in green. Basically, all types of positive and negative correlations between the two variables are still allowed by the theory. If we make the theory a bit more specific, then we move on to alcohol consumptions result in poor choice quality. We're already excluding half of the potential correlations, right? Because we're basically saying only negative correlations will be in line with what this theory predicts, and the positive correlations or no correlations are excluded. So you can, if you imagine the red lines to be potential falsifiers, then you could say that the second theory contains more potential falsifiers than the first theory. So in that sense, the second theory is better falsifiable than the first theory, because it contains more classes of falsifiers, right? There's more potential data that could falsify the theory. If we now move on to only extreme alcohol consumption leads to deteriorated choice quality, then the class of potential falsifiers becomes even larger, right? We're not just a simple linear relationship is excluded here. We're specifically saying that there's no change in choice quality up until a certain point of alcohol consumption, and then the quality of decision-making deteriorates. So that makes a very specific prediction about the data that would occur. And if you then make our measurement more specific as well, so we have 3 measurement points, right? When people are sober, when they've drunk 3 breezers, and when they're completely drunk, then the potential class of falsifiers becomes even larger than in the preceding 2 examples, right? Because any positive or negative or correlation or flat relationship or lack of correlation is excluded by the model, and only one specific type of deterioration is predicted. So we would argue, arguably, this third theory is even more falsifiable than the preceding one, and of course the one before that. All right. So basically what you do with this criterion, falsifiability, is look at the degree to which, you look at 2 competing models, say A and B, and you look at do they fit the model. And if you say, well, they both fit the model equally well, then you should prefer the model that's more falsifiable, right? Because basically in Popperian terms, you would say, well, the test for the more falsifiable theory was more severe. It has been more severely tested. So the verisimilitude, I'm sorry, I'm struggling with that word, the truth likeness of that theory is greater, because we've exposed it to a greater challenge basically than the other theory, and it survived just as the other theory. So we should prefer the one that we've put to the test more stringently. So that's what you do with falsifiability. It's not just a case of saying it's either falsifiable or not. No, we can talk about degree of falsifiability, and this is how you use that criterion. So if they both predict the data equally well, then you can look at which theory has been put to the test more strongly. So which theory is more falsifiable than the other. Right, so we're also going to talk about the 6th and the 7th criterion. Post-diction is described in the reading, so you can read about that there. It's about the degree to which the theory is informative to explain the data after you've done the research. Not necessarily to predict the data in the strictest sense before you do the research, or predict behavior in advance. But I think the 6th and the 7th are more important criteria, just as the first 4 are. Let's talk about parsimony. So, which theory is more parsimonious? So, I would argue that the theory about introspection leading to worse decision making is more parsimonious than supposing that something exists, the unconscious, that somehow crunches the data in a more efficient way and leads to a better decision. So, in this comparison, my preference would be for that the first of 2 approaches. But you could argue this choice, right? So you could argue whether saying that introspection leads to worse decisions compared to unconscious thinking leading to better decisions. I mean, you could also say they're about even in how parsimonious they are. They both presuppose a unspecified, at least in my version of the theories, unspecified process, introspection or unconscious thought. But there's another criterion that you need to take into account. All right, so the degree to which a new theory is original compared to the existing ones. And the unconscious thought model in this comparison followed the theory about introspection. And you should then compare the 2 and say, well, what does the new model basically add to the existing one in terms of testable predictions? That's basically what we're talking about here. Not necessarily originality of thought, right? So, oh, wow, you thought of a creative or original idea, right? We never thought about that before. No, we're talking about to the degree to which new theories generate testable predictions that we didn't have before. In terms of the smart unconscious or unconscious thinking, as I've described it in this video, I didn't describe the full thing. So if you're interested, please read the book or read up on the related research. But as I described it now, we didn't really it didn't really generate new predictions, right? So in both cases, in the old theory, we could predict the same data as with the new theory, right? They both would predict people that didn't think carefully about their decisions outperforming the individuals that did think carefully about their decisions, only for different reasons, but the results they predicted were the same. So in that sense, the new theory isn't that original, or in the sense that it doesn't generate new testable predictions, and that's an important criterion. So, wrapping it up, we've talked about 6 different criteria which you can use to decide on your preference between 2 competing theories, right? So you should, at the very least, know what those, the 6 we discussed, imply. So you know that descriptive adequacy is related to how well your theory accords with the existing data, so how well it fits the existing data, or is disproven by the existing data, but that's in principle not enough to decide between 2 competing theories. So we should also always look at precision as well. Is one theory more precise than the other? And often if a researcher provides a formal model, it's easier to ascertain which model is more precise and what the actual relationship is that is predicted by the model. The precise relationship is that's predicted by the model. You can look at coherence and consistency, both the internal logic of the explanation. Does it make sense? Are all the different parts of the theory well connected? And you could also look at consistency. Is it well aligned with other existing theories, evolutionary theory or theories from physics, right? So the BEM article would be another example, right? Stuff from the future influencing the past doesn't really isn't really consistent with other research results from psychology, but also from outside of psychology. So that's coherence and consistency. Falsifiability, by falsifiability we mean, well, basically 3 different things. We mean the classical approach, as you're familiar with, but does my theory allow me to predict something which is falsifiable? So does it lead to predictions that can be potentially falsified by doing observations? It's also relatable to the disposition of the researcher. Are you doing everything you can to try and disprove your theory, right? It shouldn't just be potentially falsifiable. No, you should be active in going about your research and trying to falsify it. And the third one is the degree of falsifiability, by which we mean, which is highly related to precision, as you probably noticed, by which we mean that the more specific your prediction is on the basis of your theory, or the more potential cases of the data you could collect, so the more patterns in the data your theory excludes, the more falsifiable your theory is. And if you have a comparison between 2 different models and both predict the data well, then you should prefer the more falsifiable or the more precise prediction or theory. We talked about parsimony. All else being equal, you should prefer the explanation that's more parsimonious, that doesn't rely on very convoluted or complex explanations, because there's no reason to presuppose those more complex relationship if the 2 theories are equally predicted of the data. And we talked about generativity or originality. So to what degree does a new theory that's been developed introduce new testable predictions compared to the old? All right, I hope that helps in studying these different criteria. If not, let me know on the discussion board or in the Q&A in the final week of this course. All right, see you later.